Welcome to another edition of practice of Kubernetes with Kodekloud, which is a cloud platform, an online platform to practice your cloud and DevOps and sysadmin skills. We'll solve a series of exercises linked to volumes and persistent volumes in pods in Kubernetes by answering these 19 questions or maybe even more. We have deployed the pod, inspect the pod, and wait for it to start running. So let's first of all get the pod. It's actually already running. Okay. The application stores the logs. That's the application on this pod stores the log inside this file. View the log. So the log, this file is actually inside the pod. So how can we do to view them? First of all, we need to connect to the pod, and it's something like this. Connect to the web app pod, and then we are going to display the file. This is the log file. We can see that user 5 has login issues. User 7 has item or stock or purchasing issues. Okay. If the pod was to get deleted now, will you be able to view these log files? What we need to know here is normally that log file is inside the pod. So if the pod has to disappear, normally that file has to disappear, except if it was mounted out of the pod in a place where the file can be accessed, the file can continue to live. For us to know that, we need to actually check it to be sure. So I can do a get pod and look into the web app pod and look at the definition file and check if the var log, I've forgotten the name of the, let's see, the name of the file was log app.log, and see if it's mounted out of the pod. So we can look at the volumes here. So it's not mounted here, which means in the volume mount part, it is, we cannot use it there, we cannot see there. So if this pod disappear, the log file is going to disappear. So we say no here. Now configure a volume to store these logs here on the host. So on the host where this pod is running, we're going to store the log file inside here. So I'm going to reopen the pod definition file for the pod that is running. Get pods, the pod name is web app, and displayed in a YAML format and redirect into a file or YAML format, and then we're going to open that file, and then we'll go where volumes are mounted, and we'll mount a new pod. So I can look for volumes. These are the volumes. This is one that is mounted here. I'm going to mount the other one to store logs. I'm going to call this the web app log with the S, logs, and I'm going to do the, I think it's a host path, something like that. Let's check it here on the Kubernetes documentation. Let's look for volumes. And this is how a volume is mounted here, but this is an EWS, I said W, as in French, EWS, EBS store. We'll look for something that has to do with the local host. We call that the host path. I'm going to search for host path so that we can grab the syntax, something like this. We can add the path property to the host path. So I'll come back to the port here, and we say host path. I want to check the spelling, if it's camel case, host path, and I'm going to add the path which will correspond to this. So this is a volume that is mounted, that is defined, not mounted, it's defined on the port definition file. Now we're going to mount it on the port somewhere here. So the mount path is you can check it here, and the exercise, the mount path is /log. So we're going to mount on /log a volume that corresponds to this name, the web app logs here. And then we are going to delete the port and remount the port, because we just changed the port definition and added mount volumes. So we're going to delete the port, web app, taking some time to delete the port. Okay, and then we're going to remount the port with the new configuration. So we're going to apply this and check everything is okay. Now we're going to create a persistent volume with these characteristics. I'm going to check here the syntax for creating persistent volumes. And we're going to adapt that to the exercise. So I'm going to take any one and copy. This is a port. That's a persistent volume claim. This is a persistent volume with less parameters. I'm looking for something that is a little bit complete. Something like this. Capacities and the rest. So we're going to copy this one. And I'm going to create a persistent volume YAML file and paste, and then we modify with respect to the exercise. So what's the name? The name is pvlog. Yeah, pvlog. The capacity is 100 megabytes. 100. So I'm going to make this a little bit larger. Okay, so we have 100, and then the access mode is read write many. You can see it here, read write many. And then the host path, so this is mounted on an NFS storage, but we'll mount it on the local machine, on the node in which the pod is running. So we'll call this host path, and the path is /pv/log. No IP address. We're going to remove things like this that is not asked in the exercise. Reclaim policy is retain, so we change this recycle to retain here. So the one I copied was mounted on a file system, NFS file system, where this one is on the host path, so we'll delete this line. And that is as simple as it can be. We'll delete the mount options too. That's the simplest one we can have. I'm going to save the file, and then we're going to apply all of that configuration and check, and we are good to go. Next, we are going to create a new persistent volume claim. I'll do the same thing. I'll come here and I'll check for persistent volume claims. I think I saw one here. This is one with very few options. We'll look for something that is complete. This is a persistent volume. This is a persistent volume claim. We'll copy this one. So I'm going to create a persistent volume claim YAML definition file, and inside we're going to paste, and we'll start changing. So what is the name? The name is claim log. Yeah, copy that and change this name. The storage requested is 50 megabytes. Change the storage here, and then the access mode is read write once. Copy that and change the access mode here, read write once. It's already correct, and we'll remove every unnecessary information like this one. We can remove the volume mode, and that's the simplest configuration we can have. Save the file and apply the changes and check. Good to go. Now, what is the state of the persistent volume claim? We can say kubectl get persistent volume claim. Persistent with the T. The easiest way is to do kubectl get pvc. So the state is here, pending. And what is the state of the persistent volume? The same thing, get persistent volume or get PV. So basically, persistent volume is like configuring a hard disk somewhere where many ports will come and take small chunks of it to use for their personal use. And how does the different ports take the small chunks? They will come with your different small claims. Like this one will configure, like the PV will be something like 500 gigabytes, and then a PVC will be something like inside the 500 gigabytes. I want to use just 2 gigabytes. Can I have a permission to use a small fragment of the 500? That's the difference that exists between PV and PVC. So what is the state of this PV? The state is that it's available. Of course, we just configure the PV so it's available to be used by PVCs, by claims. So it's actually available. Now, what is the claim not bound to the persistent volume? Now, this is the persistent volume here. And the first thing to look at when it's usually not bound is the access, the reclaim policy, the access modes, and maybe if they're in different namespaces. But let's look at the reclaim policy on access mode. So if I display the PV configuration, it looks like this. The access mode is read write many. So normally any pod that wants to have access to this volume should come in a read write many format. But if I look at the PVC that was configured, it's read write one, so they have access mode mismatch. So we'll have something like this, access mode mismatch. Now update the access mode on the claim to bound it to the PV. So we have to look at the PV. This is it, persistent volume. It's configured to be read write many, so we're going to do the same thing and put it on the PVC to be read write many here. So change this file to read write many, and then I need to delete the whole PVC and recreate it from the modification. So keep CTR, delete the PVC, this is the name, and then recreate another one. And check, and it's good, and I can actually recheck again. Remember it was pending. I can actually recheck what it becomes. It's bound to the volume, this. So next, you requested for, that's something I forgot about. Let's check again. This is the PV. So it was configured to be 100 megabytes, but what about the PVC? It came to claim half of it, like 50 megabytes. So the question is, how much capacity is now available on the PVC? On the PVC, the truth is that there is one-to-one relationship between the PV and the PVC. So even though it claims half of the hard drive, it will actually be bound to all of it. So the real capacity available is actually 100. Now update the web app port to use the PVC as its storage. So if we go back to the port definition file, we had a mount volume for the log file here, and that volume actually corresponded to a volume that is on the host where this port is running. So instead of using the host, we want it to use the PVC as the volume that was configured for persistency. So we're going to change this to match the PVC that was configured. So I'm going to change this thing. Instead of host path, I'm going to delete host path. Let's keep the same name so that it's easier, because this name here is actually already configured on the mount path up here. So if we change the PVC, it's going to be the same name, so everything will just function normally. So instead of host path, it needs to be something like persistent volume claim. We'll see. We need to look for a port. This is a port, for example, that uses a persistent volume claim. So we'll use this. This is a volume that comes from a persistent volume claim, and that persistent volume claim, I claim this persistent volume claim name, my PD, is mounted here. We're doing the same thing. Let's copy this and let's come under here. We're going to put the name of the claim here. The name of the claim we configured was claim log 1 here. Let's change, let's save, so just to verify that the name was claim log 1. If I do a kubectl get pvc, I can see that it's claim log 1. So I've configured that port to be able to use this particular PVC to store and persist its data. But we'll just change the configuration here. We need to apply that. So I need to delete the port. Delete the port, web app. Taking some time, and then reapply the port, web app, and let's check. It's running very well. Next, what is the reclaim policy set on the persistent volume? What is the reclaim policy? What if I will do a kubectl get to get the persistent volume? The reclaim policy is retain here. Yeah, retain. What will happen if the PV to the PV if the PVC was destroyed? Right, so this is a PV, it says retain. What if we destroy the PVC? What will happen to this? Retain means information is going to be retained. Normally the PVC comes and claims this particular storage block. Now, just that this storage block has a retain policy, meaning that if the PVC is destroyed, this block will continually retain the data that was inside, and it will not be made available for other ports. It's going to retain the fact that it needs to be bound to the same PVC. Another PVC will not come and use it. It will be retained for the former one if you wish. So you can say the PV is not deleted, but it's not available either, something like this. Now try deleting the PVC. First of all, where is the PVC? This is it here. It's called claim log 1. So let's try to delete that. kubectl delete PVC. If the command hangs, you can use Ctrl+C to get back to the prompt, or check the status of the PVC from another terminal. So if I go to another terminal here, it says check the status of the PVC. So if I do kubectl get PVC, it's being terminated. It's terminating, but it's not yet terminated. So here it is terminating, something like that. Well, still stuck here, so I don't know what to do next. Why is the PVC stuck in terminating? My guess is that since it's mounted on the port is still using that storage, so it cannot be terminated like that. Remember, when we configure the port, let's go to the terminal that is still available for us. So if I display the definition file for the port, somewhere we have the persistent, the PVC that was configured there, so that port is still using that for storage. So I think that's why it's being it's trying to terminate, but it's still in use, so it's getting stuck here. So I would say the PVC is being used by a port here. Now let's delete the port. So I'll just do Control C to come out of this thing, and I'll just skip CTL, delete the port. The port's name is web app. Taking some time there for deleting. Right, this is deleted. I can benefit to check KCT to check again the status for the PVC this time around. Normally we deleted it, but it was still in the deleting phase because the port was using. So let's check it out again. kubectl get PVC. Well, the PVC is gone, so it's gone, and the port 2 is gone, and we should only be left with the PV, which is released because nobody's using it. All right, which was first claimed by this guy here. All right, so let's check. Everything is gone. Next question. Now, what is the state of the PVC now? The PVC is deleted. Actually, we just checked it here. What is the state of the persistent volume now? We just checked it here. It's actually released. Here, released. And final question. We're done. So thanks for viewing, and don't forget to subscribe, and we have multiple other exercises coming for this Kubernetes journey that you're going to benefit from the live sessions. Might have discovered this series is not about teaching the fundamentals. You need to have another tutorial somewhere, but it's doing practice sessions so that you can at least learn from the concepts from actually practical exercise on Kodekloud. Now thanks for viewing, and see you on another video.